The plant produced over 1,000 pounds of fertilizer per day. It employed 5 full-time workers, but without a full-time engineer. Management was located over 500 miles away in corporate offices, but communicated via Skype at least once a month. The total capital loss of the accident was over $1 million. At the break of dawn, on Monday, March 17, 2008, the Tri-County gas and fertilizer production plant burst into flames. A devastating explosion, measuring 7.5 on the Richter scale, shook the quiet town. Unfortunately, all of the plant workers were killed. The explosion destroyed Main Street and was heard from the nearest town over 25 miles away. Only pieces of scrap metal remain from the #1 soybean fertilizer maker in the United States. Local citizens reported ruptured eardrums from the overpressure, while multiple houses collapsed. Ouch! The Organization for the Understanding of Chemical Hazards was called to investigate the accident because the Chemical Safety Board investigation team had been diagnosed with chickenpox.
An incident can include an injury, illness, fatality, or close call. Investigation of incidents follow OSHA protocol as outlined by the Department of Labor. Here is the OSHA incident investigation process diagram. The first step, which occurs before any incident, is to prepare your team for the future. This includes specifying who and how investigations will be performed. After the incident, the team selected and trained by the company will perform or enact the investigation. For this step, quick response and careful attention is necessary as the team gathers first-hand information and testimony. After collecting the evidence, the team will analyze the data and testimony to successfully prepare a report. The analyze step includes determination of causal factors as well as determining corrective measures. A report with the findings of the investigation will be created and distributed. Finally, it is the role of the team to implement corrections to problems, distribute information, and ensure changes are implemented and improved.
Case 1, Forklift Overload. Tammy Lynn was known as the fastest forklift driver in the county and broke the Tri-County forklift land speed record. Investigators proposed that Tammy Lynn was speeding and lost control of the forklift, striking a high-pressure tank containing explosive material. Fire and explosion safety with respect to exiting vapors. Fires and explosions require three components: a fuel, an oxidizer, and an ignition source. Static electricity is generated when vapors pass through the orifice. A charge may accumulate and discharge in a spark. If flammable vapors are present, a fire or explosion could occur. In this case, the vapor coming from the gas in the tank acted as the fuel, while the air acted as the oxidizer. Static discharge ignited the venting vapor. Investigation. The Ouch investigation revealed that the plant was currently operating with high pressurized tanks containing flammable gases. The tanks were not designed to withstand a collision force to at least 1/2 the weight of the tank. The tank should have been isolated or protected by a barrier. Ouch proposes that a possible ignition source was the static electricity generated from the vapors passing through the orifice of the tank. Based on the investigation, Ouch suggests: 1. Protection barriers should be placed around high-pressure tanks. 2. Reduce forklift operating speed. 3. Forklifts should not be used around pressure vessels.
Case 2. External ignition that led to the tank explosion. A high pressure and temperature tank containing potentially explosive material was coated in a flammable substance. The substance was an experimental hydrocarbon-based polymer that has been described as a cross between flubber and Nickelodeon slime. Plant operators had just completed a slime war, which caused the polymer to be scattered throughout the plant and process equipment. Fire and explosion safety. Unfortunately, in this particular case, the hydrocarbon polymer acted as the fuel, while the atmospheric air acted as the oxidizer. The Ouch investigation revealed that the plant was currently operating with outdated and unmaintained electrical systems. Documentation shows that frayed electrical wires were common throughout the plant, along with damaged electrical outlets and connections. Poor housekeeping led to tangled electrical wires and process equipment. Ouch proposes that a possible ignition source was the frayed electrical wires in contact with the flammable polymer. After combining with oxygen in the air, the resulting fire compromised the pressurized tank. If the initial fire or explosion was isolated from the pressurized tank, significant damage could have been avoided. Based on the investigation, Ouch provided the following suggestions. 1. Do not have slime wars inside the plant. 2. Prevent combination of flammable components with oxidizers. 3. Always assume an available ignition source. 4. Replace all frayed or damaged electrical wires, outlets, or connections. 5. Isolate potentially dangerous process equipment. 6. Install secondary blast barriers to contain ballistic explosion damage.
Case 3, Pressure Pickle. The Ouch investigation suggests the possibility of a problem in design and operation of a pressure relief valve. Evidence found after the explosion reveals that a crucial relief valve was designed and installed improperly. Further investigation showed the plant safety valves were poorly maintained for the years leading up to the accident. Under normal operation, a pressure relief valve is used as an important safety feature for vessels under pressure. As pressure in the tank increases due to an unscheduled event in the process control system applies pneumatic pressure to open the valve. This allows for excess pressure to be released. After the excess pressure is released, the valve closes. This can be repeated indefinitely and ensures safe operation of the process. However, the mode of the valve operation is important. For any possibility of overpressurization, the valve should be able to open without a control system. This is known as fail-open valve operation. On the day of the accident, Ouch proposes that the control system was unable to open the valve, or the valve was improperly maintained. This inability to reduce operating pressure resulted in the rupture of the tank and a subsequent explosion. Ouch recommends pressure relief valves that use springs or diaphragms to operate without external control systems. Ouch suggestions. Specifically designed pressure relief valves should be used on all pressurized vessels. Secondary safety valves that do not require control, power, or air supply should be used in addition to controllable valves. Routine maintenance and inspection of all safety valves within the plant. In conclusion, the actual cause of the catastrophic explosion is unknown. Through the process of accident investigation, 3 major issues have been identified in company policy, implementation, and behavior. The dangerous culture of speed and negligence around forklifts should be reviewed and eliminated in further company actions and development. Worker handling of novel materials around existing and dangerous plant operations should be minimized. Dangerous and volatile high-pressure systems should be inspected, evaluated, and if necessary, changed at regular intervals. Furthermore, all safety systems should be re-evaluated and implemented in light of the findings of the incident investigation. Incident investigation is an integral part of ensuring any accident is critical learning time for a company. Learning from the mistakes of the past can allow a company to move ahead after times of tragedy and destruction and prevent future problems.